Okay, welcome back to the second part of our cost lecture. So we're going to be talking about graphing all of our cost data. And these graphs are going to allow us to see the relationship between the curves and the relationship to output. So let's examine the relationship between variable cost and the production function. Now, what we see here, this is a production function. This shows us how output changes as we hire more workers. So this is the number of workers. These are the number of units. And you can see when we hire the first 4 workers, and by the way, this is showing how each worker adds to the total. And the difference between these two numbers is their marginal product. For example, you have 0 workers, you have 0 output. Hire 1 worker, you have a total of 4 units. You hire 2 workers, you have a total of 14 units. But the marginal product of the second worker is 10, meaning output increased by 10 when you hired that second worker. That's what marginal product is. Marginal product is a change in total output when you hire one more worker. So the distance, or excuse me, the amount between the two numbers here is the marginal product. And you can see from 0 to 4 workers, this production function is experiencing what we call increasing returns of scale. That's a fancy way of saying each additional worker is producing more or contributing more than the previous. So the first worker contributed 4 units. Where's my cushion? Here. The second worker contributed 10. The third worker contributed 13. And the fourth worker contributed 16. So each additional worker was more productive than the last. That's increasing your return to scale. And interestingly, this production function, this line, you can see increasing returns by the steepness of the slope. The steeper the slope, the increasing returns to scale. As the line flattens out, that shows decreasing returns to scale. But as long as this line is sloping upward, output is increasing with labor. So there's your increasing returns to scale. 4, 10, 13, 16. And since we're paying each worker the same amount, if we're paying each worker the same wage, you can see how unit labor costs are falling because the fourth worker who gave us 16 units is being paid the same wage as the first worker who gave us 4 units. So costs must be falling. So take a look at this. Here, keep your attention on the productivity, the marginal product. And as marginal product rises for 10, 13, 16, marginal product, as marginal product falls, marginal costs starts to rise. So here, go back here. See, as the workers become more productive, 4, 10, 13, 16, look at what's happening to marginal cost over here. Marginal cost, the change in total cost when you produce one more unit, is falling. That makes sense. When productivity goes up, as seen by this increasing number, marginal costs are falling. They're inversely related. And as marginal product falls, marginal costs start to rise. So marginal product is falling, as you can see right here. And as it falls, marginal costs over here start to rise. So what does this tell us? That means you got to pay attention to how many workers you hire. Because as you hire more workers, keeping other factors of production fixed, uh, productivity is going to eventually fall for workers. And that means your costs are going to start rising faster and faster. And this relationship can also be seen by looking at the variable cost curve. So here's our production function over here. And here we see our variable cost curve, how this tells us how costs change as we change output. Keep in mind, these are workers, this is output. And when this curve is kind of flat, that means costs are not rising that rapidly as we produce more. That could be the reason why is maybe workers are more productive, the steep part here. But as the marginal as productivity starts to fall, costs start to rise rapidly. Here's an example of a cost situation. Suppose the production is given by Q equals 3K. In other words, here's your machines, here's your labor. If you tell me how many machines you have, and you tell me how many workers you have, I could plug it in into this function, and I could tell you what output is. Okay, that's what this equation means. And now we need to know how much does it cost to rent a machine? Well, $2 per machine hour. How much does it cost to hire workers? Well, $24 per person per hour. That's our costs associated with the amounts. And of course, our capital is going to be fixed. The number of machines we have is 4 right here. But the number of workers is variable. So let's graph this. What needs to be done first? Well, first determine how much capital and labor are required to produce a given level of output in the short run. So K is fixed at 4 machines. So the required amount of labor is found by solving this. So we're just plugging 4 for K. And then we could solve for L. And so basically, um, we could determine the now if we want to produce 10 units, we plug 10 into here, and that will tell us how many workers we need. So all we're doing is trying to figure out how many workers we need given our output. So since L can be viewed as Q divided by 12, we could plug that in our total cost function. Our total cost is fixed cost plus variable cost, and fixed costs is the rental rate of capital times K, that's this, and our variable cost is wage times L. So what we can do is we could take this L and we could substitute this for L, and it'll look like this. So see this? This is the substitution here. We just substituted this number, which is equal to L, right here. And that's what we see right here. And we take L, which is represented here, multiply it by its wage, $24. We take 4 machines, multiply it by its rental rate, which is $2 per hour. And if we simplify here, we're going to get a total cost equation, which is equals 8, 2 times 4, plus 2Q, which is this. That's what this simplifies. This is the simplification of this. So we see that fixed cost must equal $8 because this does not change. When we increase output, it doesn't affect this. So if we produce 0 units, plug in a 0 here. This part becomes 0, right? So total cost equals 8. That must be fixed costs. Variable cost is this part right here. So variable cost equals 2Q. So if we could graph this information, right? We could graph 2Q and we can graph $8. See, $8 is just a straight line, meaning as Q increases, it doesn't affect fixed cost, which always stays at 8. But variable cost changes. It's 2 times Q. So the slope of this line is 2. As you increase output, variable costs increase by 2. So the other costs we'll be dealing with are easily derived by the total cost equation. And so marginal cost is an analysis that simply looks at the last unit you produced. Now, average cost analysis looks at an entire range of output. So when you say the average cost is $4, that means if you produced 100 units, all 100 units on average cost you $4. So what you're doing with an average analysis is you're looking at an entire range of output rather than the last unit produced. So we have average fixed cost, which is simply fixed cost divided by Q, right? And we've got average variable cost, which is variable cost divided by Q, and average total cost, which is you add the two together. Average fixed cost plus average variable cost equals average total cost. So we can graph these. Um, Remember, fixed costs do not change, but average fixed costs slope downward. So as Q increases, average fixed costs fall, which makes sense, right? Because the denominator fixed costs stay the same, but the numerator fixed cost remains the same, but the denominator Q increases, so average fixed cost falls. If your upfront costs of production, if your fixed costs are $200,000 and you produce 1,000 units, your average fixed cost is going to be $200 per unit. But what if you ramp up production? Now you produce 20,000 units. Well, your average fixed cost is going to fall down to only $10 a unit now. So the process whereby average fixed cost falls with output is often referred to spreading your overhead costs. And the AFC, average fixed cost, does not have a minimum because it's always downward sloping. So geometrically, to find the minimum ABC, so take a look at your um, average total cost, your average variable cost. A lot of people are very interested in when do these curves bottom out. That tells you the rate of output that's going to minimize your costs on average. So basically, the way we do that is you draw a ray, a straight line, from the origin in this graph up top until it's tangent, until it just kisses the variable cost curve, like so. And that point will show you the minimum of the average variable cost. See right there? So Q sub 2 is going to give you average variable cost, which is right down there. See? Similarly, you could do the same thing with total cost. You take a ray from the origin and draw it until it just kisses the total cost curve, right like this. And that's that point right here. And now Q sub 3 is the rate of output that will minimize your uh, average total cost. Finally, the minimum marginal cost curve, we use a rate that finds the minimum there too. See? So let's go over a math problem and then we'll save that for the next video. So that will be video 3.